here. Again, we have a quantified argument to begin with, and we want to determine if this argument is valid or invalid and to give some sort of diagram that supports our conclusion. So it says all cats are domesticated, and we know to draw that we would put the set of cats completely inside the set of domesticated things. And some tigers are cats. Now remember, we're going to try to draw a picture which is a counterexample. So the question is, can we draw this? If so, the argument that is invalid. If not, if we can't draw that, the argument must be valid. So remember, we try pretty hard to draw that, and if we've considered every possibility and we can't come up with this kind of picture, then we know the argument must be valid. So we've certainly got the first premise to be true. Some cats are tigers. Now we need to have a set of tigers, which would be called set T, to come in and touch set C. Okay, so we're going to have T come in and somehow intersect with set C. But some tigers being domesticated, we want to not have true. That is, we want no tigers to be domesticated. So the question is, can we draw a set T so that it will come in and touch C? That is, so there will be at least one tiger that's a cat right there. That would be the tiger that's a cat, but we don't want that tiger to be domesticated. And you can fairly quickly see that there's no possibility of drawing a set T so that it intersects C, and there's something in that intersection, but that there are no tigers inside of the domesticated things. So this argument is valid because we can't draw a counterexample. And let's check. So we have the argument valid, and let's see. So certainly we can eliminate the choices in which the argument is invalid. We can eliminate this one and this one because they draw the wrong conclusion from this question. So it's one of these two. And you can see here in this picture, it doesn't satisfy the premise that some tigers are cats. So this in no way shows that the argument's valid. This is the picture that best supports the conclusion that the argument is valid. Okay. And again, you can see it's fairly close to our picture. All right, let's look at the next one, or the last problem. No, it's not quite the last problem. I think there might be some more. It asks us to translate the argument into symbolic form and then determine whether it's valid or invalid. And if I eat my vegetables, P, then, if then, I will be healthy, Q. So we have P arrow Q. I didn't eat my vegetables is not P. And the conclusion we can see is I will not be healthy. So certainly we can strike out some of these because they have incorrect diagrams. For example, this one is incorrect diagram, so it doesn't matter. And let's see, this one has an incorrect second premise. It says not Q instead of not P. So let's go ahead and see if we can figure out whether this argument's valid or invalid. And again, if you happen to know a little bit about patterns, you can conclude that this is an invalid pattern. It's called the fallacy of reasoning by the inverse. But let's go ahead and try first with the truth table and then with this bad row method. Okay, so we'll start with P's and Q's. And we're going to need some help rows. We're going to need P arrow Q. We're going to need not P. We're going to need the conjunction of those two, P arrow Q and not P. And I would like to have a not Q right next to it so that my final column, that is the argument itself, which would be P arrow Q and not P together imply not Q. So the question is that all trues or is it not? So we fill this out, true, true, false, 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 true, true, false. Let's make sure we get 4 different ones. So true, false would be the 4th one. P arrow Q, and again, just some calculations. That's true, that's true, that's true, and that one is false. The negation of P would be false, true, true, false. The conjunction, or the and of these two, would be false, true, true, false. The negation of Q column, coming down here, we'd see would be false, true, false, true. And now the implication, false arrow false is true, true arrow true is true. So far so good, and right there we can stop really, because we know that this is the bad row, which we'll find in a different method, and so the argument is invalid. And if you wanted to check the last one, it's actually true also. Okay, so we know the argument's invalid. This is the bad row, and let's go ahead and see if we can find that a little bit more directly. So we know the correct answer is C, the argument is invalid, but let's try the bad row method. Okay, which asks us to see if we can find a scenario in which the 2 premises are true, but the conclusion is false. And there's only, again, 4 values for P and Q. True, 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 false, false, true, and false, false. Okay? Well, let's see. We know according to this, if not Q is false, and I'm going to put a question mark up there. If we can find this, then the argument's invalid, and if we can't, it would be valid. If not Q is false, then Q itself must be true. So we only need to consider the cases where Q is true. So we can ignore the cases where Q is false. Okay. Again, if not P is true, that means P would be false, so we only need to consider the cases where P is false. And so, for example, the case where P is true, we don't need to worry about. So we're left with just 1. And let's check to see what happens there. Okay. Let's see, P arrow Q, false arrow true. That's true. Not P is also true. And not Q is false. So we have indeed found a scenario where the premises are true, but the conclusion is false. And so we have a bad row. We have a bad row. That is, we didn't eliminate all the possibilities. And so the argument is invalid. The argument is invalid. Okay? And if we compared that with our previous work, let's see. Right there, you can see the bad row occurred precisely when P was false and Q was true. We can see up here, P was false, Q was true, led us to that one failure of the argument. And all it takes is one failure of the argument to invalidate it. Okay. Let's check the next one. All right. Next page.